Hey everyone, let's do these Unit 5 less than 6 practice problems together. And so we're starting with this warm-up screen. It says, determine the value of the variable that makes each equation true. So our next unit that we're going to start in a few weeks, we're actually going to learn the real process for doing this. I don't want to get into that just yet, to be perfectly honest. I'd prefer that we just try to fill in the blanks based on just our knowledge of multiplication and division facts. Let me get my drawing tool out. Let me use a color I don't always use. I use blue a lot. How about this dark red today? So the first one says 3 times a equals 12. So you're just trying to fill in the blank of what goes there for a. This is called substitution. And hopefully you can do that in your head and figure out that it's a 4 that goes there. And so the next one says -3 times 4 equals what? And in the previous one, we just kind of came to the conclusion that 3 times 4 is 12. Well, -3 times 4 is -12. So in class, we might have talked about this. I'm not sure, I'm filming this in advance, but I'm going to try to remember to talk to you about this, where this works better if you have it on paper than on a screen, because the whole point of it is being able to cover it up. But there's this triangle that can help you remember whether your answer is positive or negative when you're multiplying or dividing. And I want you to imagine you have this written on a piece of paper, and what you would do, you'd take your 2 thumbs and you'd cover up the 2 symbols or the 2 signs of the numbers you're multiplying. So for example, if you were multiplying 2 negative numbers, you'd cover up those 2 negative signs I put at the bottoms of the triangle, and the only symbol you'd be able to see left over is the plus sign, and that tells you, oh, a negative times a negative is a positive. And if you were multiplying a negative times a positive, then you would cover the negative sign with one thumb, the positive sign with the other thumb, and you'd still be able to see a negative sign. And that would remind you that if you were doing a negative times a positive, you get a negative. Whenever I teach this, students always go, well, Mr. Thomas, what about if I'm doing a positive times a positive? Like there's not 2 positive signs for me to cover up my thumbs. And I just go, come on, you know a positive times a positive is a positive. You don't need that. All right, so the next one says -3 times c, but I'm just going to put a blank there, not the letter c, equals 12. Oh wait, I forgot to fill in up here. So this one should be -12. B is -12 in that one. And so here, -3 times something equals +12. So like I was just saying, since a negative times a negative equals a positive, you're going to need -4 in that one. And then the last one says blank, where the letter D is, times -4 equals -12. So since we already have a negative number here and our answer is negative, we're going to need to put a positive number here in the blank. And so it's going to be +3 this time. All right, let's move on. Too many windows open right now. I'm like all over the place. All right, so what is 5 times -2? So in the Desmos, we were thinking of this as 5 groups of -2. So think of it as you have 5 -2s all being added up to each other. -2 plus -2. I always like to put parentheses to separate the negative sign from the plus sign. Plus -2 plus -2 plus -2. And then one of the strategies we learned for adding up numbers is that if every single number you're trying to add up is negative, you can just add them as if they're positive and toss a negative sign on at the end. And so this is 2, 4, 6, 8, 10, but it's -10. So 5 times 2 is 10. 5 times -2 is -10. Next, we have -4 times 3. So this is weird because you're kind of thinking of like -4 groups of the number 3. And that's strange. And so instead of thinking of it that way, is just think of this negative sign in front of the 4 telling you that you want the opposite of. It's like you want 4 times 3, but you want the opposite of that. And the opposite just means if it was negative, it's now positive. If it was positive, it's now negative. So you could just think of this as this negative sign out here that really means opposite of 4 times 3. And 4 times 3 is 12. So you get negative 12. Or you could put the negative sign with the 3 instead of the 4. Or actually, no, you know what I should have said instead? Let's just switch the numbers around. Instead of doing negative 4 times 3, you could think of it as 3 times negative 4. You're allowed to switch numbers like that when you're multiplying. That's called the commutative property. And so this is just negative 4 plus negative 4 plus negative 4. And just like the last screen, since they're all negative, you just add them up and put a negative sign on there. 4 plus 4 is 8, plus 4 is 12, but it's negative 12. So there's multiple different ways you could think about this question, but in the end, hopefully you come to the answer negative 12. All right, next. A submarine starts at 0 units and has groups of 3 floats. So the floats on this submarine come in packs of 3. You can only take them off or put them on in groups of 3. And the anchors are in groups of 4. So you can only put them on or take them off in groups of 4. And so we have to select all of the expressions that would make the submarine's final position positive. All right, and so the submarine starting is 0, it says here. Because of that, really all we have to do is determine which of these expressions equals a positive number. Let's remember our PEMDAS. Right here we've got multiplication and division, and those both come before addition and subtraction. So what that means for us is that in every single one of these, when we evaluate them, which means to figure out what they equal, we have to do all of the multiplications first. That's what it means when 2 numbers are up against each other in parentheses. It's another way of writing, let's multiply them. So we do multiplication first, and then the addition or subtraction that's in the middle, that's last. All right, so here, let's do the multiplication first. Negative 5 times 3 is negative 15. And then we're going to add that to 2 times negative 4 is negative 8. Both numbers are negative, so I can just do 15 plus 8 equals 23. Put a negative sign on there. So that one's not going to turn out positive, right? Like the question's asking, so don't check that one. Next, we have 5 times 3 is 15 minus 2 times negative 4 is negative 8. And so here we've got 15 minus negative 8. You should remember that subtracting a negative is the same as adding a positive. So I like to literally switch them to plus signs like that. And we get positive 23. So you should definitely select that one. I'm going to switch to a new color so it's easier to see what I'm doing here. So the next one I'll do in blue. Here we got negative 15, right? Negative 5 times positive 3 is negative 15. So for me, I'm already thinking there's no way this one can come out positive, because I know that 2 times 4 is 8. Whether it's negative 8 or positive 8 or whatever, it doesn't really matter. There's no way I can get back to positive above 0 from negative 15 using an 8 of any kind, using a negative 8 or a positive 8. It's just not big enough. So I'm already confident this one's going to be negative, but let's finish it. So the next thing I see is a minus sign. And then I see 2 times negative 4, which is negative 8. Well, minus a negative is the same as adding a positive. So this is negative 15 plus 8. I mean, we went in the positive direction, but we're still negative. The answer is negative 7. All right, let's do the next one. I'll pick a different color. We'll use this green. All right, we've got 2 times 3, that's 6. and then a plus sign, 5 times negative 4, which is negative 20. 6 plus negative 20, that's negative 14. So that's not going to be positive either. So we've had 3 no's and 1 yes so far. So if they're half and half, the next 2 will turn out positive. Let's see. I don't know if they did it that way or not. I'm going to switch to this purple color. And we've got negative 2 times 3, so that's negative 6, minus, notice I always look at that the operation symbol and carry it over. Like I look at, oh, this was a minus sign, and so I wrote a minus sign over here. It got changed to a plus sign because the next number was negative, but I always look at my operator symbols and like make sure to keep track of them and don't just like move on to the next operation, because that's how you lose plus or minus signs. So, all right, so going back to what I was doing, negative 2 times 3 is negative 6. Then I carried my minus sign over to my problem, and then 5 times negative 4 is negative 20. So do you see how if I didn't carry this minus sign over, it'd be really easy to just kind of forget about it and wind up with negative 6 minus 20 instead of negative 6 minus negative 20? Super common mistake. So I've got minus negative again, which is the same as plus positive, and that's going to make this positive 14. And so I think you should select this one. And we got one more to do. This is a long question. Geez, what's you read? 2 times 3 is 6. Carry my minus sign over. And then 5 times negative 4 is negative 20. And so again, we've got a minus a negative, which is the same as adding a positive. So this is the most positive one of all, 26. So there's our 3 that we should select. Ooh. Oh, these are all the same as from the previous screen, and it asks, so the entire question is the same. The only thing it's asking is which one of these will make the submarine go highest. And luckily, I said it out loud as we were finishing the last question. I said, this very last one is the most positive one. If I remember correctly, it came out to 26, but let's just be sure. 2 times 6 is 6. Yeah. Sorry, I think I said 2 times 6. I meant to say 2 times 3 is 6. Carry my minus sign over. And then 5 times a negative 4 is negative 20. Minus a negative is the same as plus a positive. And so I get 26. I'm pretty positive that was the highest out of all the ones we did. I think we had a positive 23 in there somewhere. So that's the one you want to select, and the position will be 26. A weather station on top of a mountain reports that the temperature is currently 0 degrees and has been decreasing at a constant rate of 3 degrees per hour. Okay, so it's going down 3 every time, and I think of the rate as negative 3 because it's dropping, right? The negative tells me it's decreasing. If I made the rate just positive 3, that would be increasing each time. So I'm going to write over here that my rate equals negative 3. And so if I want to figure out how far it drops in 2 hours, I need to do 2 times negative 3 for that one. And then in 5 hours, I'm just going to do 5 times negative 3. And so this one's going to equal negative 6, and this one's going to equal negative 15. A weather station on top of a mountain reports that the temperature is currently 0 degrees and has been decreasing at a constant rate of 3 degrees per hour. So literally the same setup as the last question. So again, I'm going to write that the rate equals negative 3. And now it's asking us about the past. Well, what was the temperature an hour ago? What was the temperature 3 hours ago? Well, the past time can be represented with negative numbers. It's like we're trying to subtract an hour from current time to go back 1 hour in time. And so we're going to multiply -1 times -3, because like the negative in the -1 is going to sort of reverse our rate for us, right? Like the rate is -3 going down, but we want to go back in time, so we put that negative sign in front of there. So it's like let's go up 3 instead, because we're reversing things. And the same thing with 3 hours ago. We don't want to do 3 times -3, because that's 3 hours in the future, and it's going to go down 3, down 3, down 3. We're like trying to pull back in time, so we're like reversing time with that negative sign, so we can go up 3, up 3, up 3. And so unsurprisingly, this is going to give us positive answers. -1 times -3 is 3, and -3 times -3 is 9, which makes sense because the temperature should be positive, right? It says in the question that the temperature is currently 0, and it's been dropping like this whole time. It says it's been consistently, is that what it says? Or it just says it has been decreasing at a constant rate. So if it's 0 degrees now, but the temperature's been decreasing, then that means previously it should have been a positive temperature, right? And it had to decrease to 0. And the further back in time you go, the warmer it should have been if it's been decreasing this whole time. All right, Tyler orders a meal that costs $15. The sales tax rate in Tyler's county is 6.6%. How much will the sales tax be on Tyler's meal? Okay, so this is a little bit of a review. And so what we have here is our whole, right? The whole original amount of the bill. And here we have a percent, which we always want to write as a decimal or a fraction when we're going to do math with it, right? And so if we have 6.6%, to turn that into a decimal, we got to move that decimal point 2 spaces, 1, 2, creating this empty spot here where a 0 is going to go. And so this is 0.066. And now we need to find that part that is the sales tax. We're going to do part equals percent times whole. And so that's going to be 0.066 times 15. And I don't have a calculator out and available to me right now at this moment. I know I could open another tab, but you're capable of punching this in. You can get that answer. 0.066 times 15, whatever that is, that's going to be the right answer there. In fact, I think you can even punch it in here, can't you? Desmos let you do that? Let's see here. 0.066. And nope, I guess not. Wait, what if I open the keyboard? Yeah, times 15 equals. Nope, it won't do it for me. It just registers it as not an answer with the exclamation point. So you're gonna have to go and get that answer. I'm gonna make you do that work. I'm gonna move on. Okay, so same setup. Tyler orders a meal, it costs $15. Sales tax rate is 6.6%. Write an equation to represent the relationship between the original cost of the meal and the cost after sales tax. Use X for original cost of the meal and Y for cost after sales tax. All right, well, honestly, all they're really asking you to do, I know this is confusing and it's hard using X and Y and variables and stuff in equations when you're first getting used to it, but we already know the relationship. The relationship is this formula that if you've been in my class, you definitely had memorized at some point. Maybe you forgot it now. Oops, geez, maybe I need to refresh because I wrote it wrong. Do over. Part equals percent times whole. This is the relationship here. Relationship, equation, same thing. Well, they want us to use X to stand for the original cost. Original, whole, that's like the same thing, right? So we're just going to put an X where I usually write the word whole. And Y for the cost after sales tax. That's sort of like our part in this case, right? And so let me just replace these two things. Y equals something times X. That's all I did is I put the Y where the part goes and the X where the whole amount goes. Now, you might be tempted to say, okay, and I remember that in the last slide, Mr. Thomas put 0.066 as the decimal version of 6.6%. And you're like, yeah, I'm going to put 0.066 to here and we're good to go. And you'd almost be right. But if you read the question carefully, there's something slightly different about this one than the last one. The last one asked us to just find the sales tax amount. This one wants the relationship for the cost after sales tax. So this is the total price, right? The cost of the regular meal without tax plus the cost of the tax. So whatever answer you got on the previous screen, because I didn't do the math, you add that to 15, that's the number they're looking for. I'm going to imagine that if it was 0.06, that would have came out to 90. So it probably came out to like 99 cents or something if I had to guess. So this answer is going to be about $15.99, but we don't want that. What we want is a number that goes here that you could multiply by the $15, the whole original amount, and get the total cost with the tax. And you only have to make one slight change. Instead of 0.066, it's 1.066. You should kind of remember doing this from when we were studying this. The 1, when you multiply it by the 15, that keeps the 15 for you. And then the 0.066 sort of tacks on the tax for you. Maybe that's why they call it tax. I don't know. That's the equation you want right there. That's how I would write it. Let's see if it says it's right. No, it's not going to tell me. Pretty sure it's right. Oh, you know what? We can check the answers down here. Let's see what Desmos says it should be. Yep, y equals 1.066x. All right, and the last one, same thing. Okay, Tyler orders a meal for $15. Sales tax is 6.6%. Tyler also wants to leave a tip between 15% and 20% for the server. How much do you think he should tip, and what would the total bill be? Do we get to, it's kind of a weird question. Do we get to just decide how much he should tip? Like, all right, now I'm curious what Desmos says they want us to do here. Oh, it says responses may vary. Okay, so, all right, how about we just pick one right in the middle? It says between 15% and 20%. So how about we pick 18%? And so you could calculate the total cost by taking $15 and multiplying by 1.18. That would get you the cost plus the tax, right? The 1 keeps the $15 in your answer, and the 0.18 is the 18% tax. And so let's see what we get there. I'll actually do the math with you this time. I'll open a new tab. $15 times 1.18. Okay, so that looks like it'd be $17.70. And then let's add on the tax. And so we take that 1770 we just got, and we're going to multiply it by 1.066, that number that we determined in the previous question. Because remember, the 1 in this number maintains the 17.70 when we multiply, right? 17.70 times 1 is 17.70. But then that additional 0.066 is that extra 6.6% for the tax. And so I'll go back and I'll do it this time. Let's see here, what do we get? 1770 times 1.066, and we get $18, and I guess we should round that up to 87 cents. So according to Desmos, it says responses can vary. I think if you choose exactly 20%, you might wind up with $19 because it's giving $19 as an option here or as a sample response. But I guess as long as your answer falls between whatever it would be if you picked 15% and 20%, there's probably a range of answers you can get in there that are perfectly fine. And just explain how you got it in your box here. So like you could explain how we got our answer if you're watching this video by just saying, well, we multiplied by 1.18 to get the tip, and we multiplied that by 1.066 to get the tax on top of that. All right, that's about it.